You replace row 2 by row 2 minus 2 R1. So what is row 2 here? Row 2 is this one, and row 1 is this. So multiply row 1. This is row 1 now in the new matrix, and this is row 2. So multiply row 1 by minus 2. So you have minus 2 minus 4 plus 2 plus 2, and then add this with row 2 to get row 2. So add them together. Add this one in the second row. So your first element will be 0. Minus 2 plus 2 will be 0. Then minus 4 plus 6 will be 2. So you have 2 here. And then 2 plus 1 will be 3. So you have 3 here. And then 2 plus 7 is 9. So you get 9. So this is now the new second row. Okay, so this you obtain from the operation row 2 minus 2R1. Okay, now on the same matrix, we perform this another row operation, which is we replace row 3 by row 3 minus 5 row 1. So again, this is row 1. Multiply this by minus 5. So you have minus 5 here, minus 10, 5 and 5. And then add this in row 3. This is row 3. So you add them together. So add them. So what do you get? You get row minus 5 plus 5 is 0. Minus 10 plus 7 is minus 3. 5 and 5 plus minus 4 is 1. So you have 1 here. And 5 plus 9 is 14. So you have 14 here. Okay. So this is your third row. This is this operation that you perform here. Okay. So now you get this new matrix here. Now in this on this new matrix, you apply this operation. Replace row 3 by row 3 plus 3 by 2 R2. So what is R2 in this matrix? This is R2. This is R2. And this operation says that multiply 3 by 2 in R2. So you multiply 3 by 2, 0, 0 multiply 3 by 2 is 0. So you have 0. 3 by 2 means you get 3 here. 3 by 2 means you get 6 by 2, and 3 by 2 means 27 by 2. Okay. And then you
9 by
add
2.
this. Sorry.
It should be 9 by 2, I think. You know, that 0, 2, 3, 3 into 3 by 2 should be, I think, 9 by 2.
3 by 2
Into 3 should be,
so 9 by us, the third increase. Okay, okay. Yeah. Thanks for the correction. So you have this this one, and then you add this with row 3. Add this with row 3 here. This is row 3. So 0 plus 0 is 0. 3 minus 3 is 0. 9 by 2 plus 1 is 11 by 2. And 14 plus 27 by 2 is 55. 55 by 2. Okay. So you get this new matrix after using this elementary row operation. So this is your new matrix. Now you can do the same operation, the one more operation, that divide. Is there any question? Can you see this screen?
No, sir.
No.
No, sir.
Sir.
No,
No, sir.
Somebody became the presenter other than you.
So do not become the presenter. Otherwise, this will disturb the class, whole class. Can you see the screen now?
Yes, sir.
Sir, yes, sir.
Yes, sir.
Yes, sir.
Okay, so now in this new matrix, you apply this elementary row operation that is replace row 3 by 2 by 11 row 3. So this is your row 3. Multiply this row by 2 by 11. So you get 0, you get 0, you get 1. And 2 by 11 means you get 5. So your third row in the new matrix is 0, 0, 1, 5. Is this okay? So finally, after all these operations, you get a matrix and denote this matrix by A. So these two matrices are equivalent. The matrix A and the starting matrix was B. So these two matrices are equivalent, row equivalent, which we write as A equivalent B. Now, if you start from the matrix A and reverse this process, that means you start from matrix A, you apply this operation, I mean, you can reverse, you can identify the elementary row operations. That means if you start from matrix A and you multiply, reverse this process, you multiply this third row by 11 by 2. So you get this one. And then accordingly choose another elementary row operation so that you get this matrix. And similarly choose suitable row operations, 2 row operations to get this matrix. And then another suitable row operation to get this matrix, which is the original matrix B. So starting from matrix A, you can, when you apply the elementary row operations, starting from matrix B, you apply some elementary row operations to get a matrix A, and you can reverse this process as well. You can start from matrix A, choose the elementary row operations to in such a way that ultimately you get the matrix B. Okay, so from matrix A also you can go to matrix B after applying some certain elementary row operations. Okay, so this is what that is why we always say that A and B are equivalent. So this is a symmetric relationship. From A to B you can go, and similarly from B to A you can go by using some sort of elementary row operations. Okay. So whether you write A equivalent to B or B equivalent to A, they mean the same thing, because from A also you can go to B, from B you can go to A. So both of them means the same. Fine. Now let us understand another important thing in this calculation. Now we start from an identity matrix of order 3. So you can consider an identity matrix of order 3, which is I is equal to 1 0 0 0 1 0 0 0 1. And then you identify some you apply these operations one by one on the identity matrix. So what was the first operation that we have applied in this calculation? We replaced R1 and R2. We interchange R1 and R2. Okay, so we interchange R1 and R2 in the identity matrix. So what do you get? You interchange this, so your first row will become 0 1 0. So you have this identity matrix, and then you apply this operation, interchanging R1 and R2. So you get your second row will become first row. Second row will become first row. So you have 0, 1, 0. And the first row will become second row. So this will be 1, 0, 0. Okay. Now apply the second operation that you have performed on B on this new matrix. So second operation you have performed on B is R2 minus 2R1. So this is your new matrix. You multiply the first row by minus 2. So you have 0 minus 2, 0, and add this with the second row. So you get 1, 0 plus 1 is 1, minus 2 plus 0 is minus 2, and 0 plus 0 is 0. So this becomes your second row after you use this operation. Now apply this operation R3, replace R3 by R3 minus 5 R1. So R3 multiply minus 5 in the first row, 0 minus 5 and 0, and add this with the third row. So you have 0 minus 5, 1. You get this one. Okay, so after using this these two operations, after using these two operations here, you get this new matrix. Okay. Now let us do the next operation, which is R3. Replace R3 by R3 plus 3 by 2 R2. Okay. So when you do this operation here, you will get this matrix. And the last one is replace R3 by 2 by 11 R3. So you apply this operation here, you get this matrix. Fine. We denote this. So now all the operations that you have applied on the matrix B, we have applied all the operations one by one on the identity matrix. So from I3, now I get a new matrix after application of all these elementary operations, basically that we have used on B. The new matrix is I3 dash. We denote this new matrix by I3 dash. Okay. Now what we see, now what we do here. Now we calculate this product. We multiply I3 dash, this new matrix that we have obtained, by using the same elementary operations on B, elementary row operations on B. These operations are used on the identity matrix. Okay. So now we multiply I3 dash pre-multiply. So keep in mind, this is pre-multiplication. Pre-multiply the matrix B, which was the original matrix, our starting matrix, by I3 dash. Okay, so I3 dash is this matrix that we have just obtained, and we are multiplying this by the matrix B. So when you do this multiplication, you get a new matrix, which is this. Okay, so matrix multiplication, everybody is aware, so I'm not going to tell anything about this matrix multiplication. You multiply first row by the first column, you get the first element, second row by the second column, you get the second element of the first row, and so on. Okay, so this is the matrix that you obtain by multiplying pre-multiplying I3 dash by the matrix B. Okay, now notice that the matrix that we obtained by this multiplication is same as the matrix that we have obtained by applying the elementary operations on the matrix B. Okay, this is exactly the same. We have this matrix B, we performed all these operations on the matrix B, and we obtained matrix A. Okay. Now we are going in different, we are doing the same calculation in a different way. We apply all the operations one by one in the sequence, in the exact sequence. First operation is this one, second is this one, third one is this one, fourth one is this one. Okay, so the sequence, you should not change the sequence. If we change the sequence of elementary operations on the identity matrix, then the result will not match. So you apply the elementary operations in the same sequence that you have applied in the on the original matrix B. Exactly the same sequence. Okay. So this product is also equal to A. And this is not surprising. And you also keep in mind that when you multiply this matrix I3, this should be pre-multiplication. If you do the post multiplication, then it will become column element. This is equivalent to column elementary column operations. Okay, so that order should be fixed. So now we say that we can obtain matrix A from matrix B in two ways: by applying the sequence of elementary row operations on the matrix B directly. This is the direct calculation that we have first performed. And the second one is you do not perform the elementary row operations on the matrix B directly. Instead of doing this, you perform these elementary operations on the identity matrix in exact the same sequence. Then you get a new matrix I3 dash. Pre-multiply this new matrix I3 dash by B. You will get matrix A. Okay. So these are the two ways you can obtain matrix A from matrix B. And these are the two ways to find the equivalence of two matrices. And this is not surprising because whenever you do the elementary operation on the identity matrix and you multiply this by the this new matrix by the original matrix B, you get the corresponding elementary operations on the matrix B, and that we will see on the next slide. So before that, let us see another definition, which is called elementary matrix.
Excuse me, sir.
Sir,
Yes.
in case of elementary column operation, we have to post multiply it.
Yes.
I3 dash.
No, you have to see the order of the matrix also. So
Sir,
what
how can we prove that
the order of the matrix is 3 by 4, right? So when you pre-multiply, that means row operation, you have I3. You start from the identity matrix of order 3. When you do the column operation, you do the column operation on I4. So when you apply this post multiplication, you do the post multiplication, you have 4 cross 4 matrix, and the product will be 3 cross 4. Fine.
sir, how can we prove that any two matrices are not equivalent always?
If you cannot get one matrix from the other using the elementary row operations, then they are not equivalent.
Yes, sir, but we can say that from an identity matrix, we can create any given matrix, right? So how will we know in so many combinations that there is no such matrix?
No, so equivalence is related to the row operations only. You do not have to mix row and column operations.
Yes, sir, but in any identity matrix, we can perform row operations and make any matrix out of it. But then how will we come to know that there is no such matrix to make them not equivalent?
Using identity matrix, how can you say that you can get all the matrices?
like we can perform row operations and we can create many possible matrices out of an identity matrix, right?
No, but not all matrices.
Right, not all, because we have to take the constraint also. But still, I don't have a rigorous proof of that fact that no matrices will be equivalent then.
So if you're able to do this, then all matrices will be equivalent. So this is not true.
Yeah,
So basically, whenever you are able to get a matrix using the elementary row operations, then they are equivalent. Otherwise, not.
okay.
Okay. All right. So now let us see this elementary matrix. Definition of the elementary matrix. So elementary matrix is a square matrix, and it is obtained from an identity matrix by performing a single row operation. Okay, so elementary the matrix of order m cross m is said to be an elementary matrix if it is obtained by performing an elementary operation, just one operation. If you do this row operation, then you get the elementary matrix using this only the row operation, and you can also do the column operation. Okay, so but the operation should be just one operation, not two operations. Like in the previous example, we have performed several operations on the identity matrix. Okay, so these are not elementary matrices. The only elementary matrices in this operation is this one, because this is the matrix that you obtain by applying the single operation of interchanging row 1 and row 2. Okay, so this is known as elementary matrix. When you do the column operations, then also it is known as, then in that case also it is known as elementary matrix. So now let us see one example, couple of examples of this these elementary matrices. So you interchange row 1 and row 2, you will get this one. So this is an elementary matrix. In the in the identity matrix, so you have 1 0 0 0 1 0 0 0 1. You apply this operation, replace R1 by 3R1. So you get 3 0 0 0 1 0 and 0 0 1. Okay, so this matrix is also obtained by a single operation, that is 3R1 on the identity matrix. And similarly, you apply R2 plus 3R3. That means on the identity matrix. Yeah. Any question? So if you do not have a question, then please keep yourself muted. All right.
ऑनलाइन मार्च तक रहेगी फर्स्ट सेमेस्टर वाला
Vansika, mute yourself.
अब ये प्रूफ ऑफ इनकम में क्या डालूं इसमें नहीं है तो कुछ नहीं डाला चलिए फॉर्म 16 में भी ब्लैंक छोड़ दो आईटीओ
Whosoever is speaking, mute yourself. Vansika. Vansika, mute yourself.
जो इसमें है वो ही इंक्लूड होगी क्या भेजना है
Okay, so now, so this is now you know what is elementary matrix. Elementary matrix is the matrix that you obtain by applying one elementary row operation on the identity matrix. Okay. So if you have a matrix A and you write this little e in front of this, so that means, and this little e is one of the elementary row operations. So you have seen 3 elementary row operations. So e is one of the elementary row operations that you perform on the matrix A. Then your new matrix is denoted by, let's say, E, A. Okay. So then there will be a row operation which we denote by E dash. If you apply this row operation on the matrix EA, then you will get the matrix A. Okay, so EA is the matrix that you obtain by applying the elementary row operation on elementary row operation E on A, and then you apply another elementary row operation E dash on the new matrix EA, so you'll get matrix A. So there will be such E dash always. Okay. So now let us consider the same elementary matrices that we have, elementary operations that we have performed in the previous example. So we have, let's say, an identity matrix 1 0 0 0 1 0 0 0. Now what are the operations that we have performed on B? First operation on B was interchanging row 1 and row 2. So apply this this operation on this identity matrix, you get a new matrix which we denote by E1. Okay. Now pre-multiply E1 with B, so you get this matrix, and this matrix is exactly the matrix that you obtain by applying the elementary row operation R1 interchanging R2 on the original matrix B. Okay. Now what is the second operation that we have performed? The second operation is R2 minus 2R1. So second operation is R2 minus 2R1. This is the second operation. So apply this operation on the identity matrix. So what do you get? You get a matrix E2. We denote this by E2. Now what is the third? And then what you do? You multiply this E2, pre-multiply this E2 by E1 into B that you have obtained in the previous step. Okay, so you have E2 E1 B. This will be equal to this matrix, and this is the same matrix that you obtain by applying this elementary row operation on this matrix. Okay. Now what is the third operation that we have applied on the matrix B? The third operation is R3 minus 5R1. So apply this operation on the identity matrix. R3 minus 5R1. So apply this operation on the identity matrix. So you get E3. Fine. And when you खिड़की से ऑन कर लिया. So when you pre-multiply this matrix by E3, you get this matrix, which is the same matrix that you obtain by applying the elementary row operation on this matrix, on the previous matrix. Okay. So now I will keep this and I will erase all these so that you can see where my pen is working. Now, what is the next operation that we have done on the matrix B? The next operation on matrix B is R3 plus 3 by 2 R2. R3 plus 3 by 2 R2. So apply this operation on the identity matrix, on this identity matrix. So you get E4. Okay. So that means you multiply this matrix by E4. You will get this one, which is the same matrix that you obtain by applying this row operation on this previous matrix. Okay. And the last operation is on that we have applied on B. The last operation that we have applied on B is R3 is replaced by 2 by 11 R3. So you have R3 replaced by 2 by 11 R3. So apply this elementary operation on the identity matrix. Okay, so you get E5. E5 is this matrix. And then use this E5, multiply this E5, multiply this E5 on this matrix. So you have this matrix. When you do this multiplication, then you will get this matrix, which is A, which was the matrix that we obtained by these operations on the matrix B directly. Okay, so what we observe from here? We observe from here that we apply the elementary, we identify the elementary matrices corresponding to each of these elementary operations. So we have performed all these operations here on matrix B. Okay, these are the 1, 2, 3, 4, 5 operations. We have performed 5 operations. Okay, so 5 operations we have performed, 5 elementary row operations on the matrix B in our previous example. So what we do now is what we are doing here is that we are performing these operations on the identity matrix one by one. Okay, so we have performed this first operation on the identity matrix to get the matrix E1. Second operation on the identity matrix to get the matrix E2. Third elementary row operation on the identity matrix to get E3. Fourth elementary row operation on the identity matrix to get E4, and the fifth elementary row operation on the identity matrix to get E5. And then you arrange this in the sequence. What is the first one? First one is E1. Then second one is E2. Third one is E3, E4, E5. And this sequence should be in the same order in which you have performed the elementary row operations on the matrix B. First we perform our interchanging R1, R2. So first you write E1. Then you write, then you have performed the second operation, R2 minus 2 R1. Corresponding elementary matrix is E2. So you write E2 here. The third one is R3 minus 5 R1. The corresponding elementary matrix is E3. So you write E3. And similarly E4 and E5. So you should always maintain the order. If you mix up with the order, then this is completely wrong. Okay, so you always keep in mind that these orders should be this should be in the same order. Now, after performing this multiplication, you multiply this, pre-multiply this by B. Then whatever you get is the matrix A. Okay. Now this matrix that we have obtained by this product E, pre-multiply E1 by E2, pre-multiply E1 E2 by E3, pre-multiply this E3 E2 E1 by E4, and pre-multiply E4 E3 E2 E1 by E5. Okay, or basically one can say that the product E5 E4 E3 E2 E1, this product, if you calculate separately, this product will come out to be equal to E3 dash, and E3 dash is the same matrix that we have obtained here. You can see that you will finally obtain this E3 dash. So E3 dash is E5 E4 E6 E3 E2 E1. You can check this calculation by multiplying these matrices. Okay, so you have this thing. You can see that when we calculate this product E5 E4 E3 E2 E1, this product will come out to be I3 dash, and this is the same matrix that we have obtained by using this elementary operations on the identity matrix in the same order. Okay, so you have another way to interpret this result. Okay, let me erase all these things. This is coming again. I don't know why. Anyway, so from here, what we observe is the following.
The screen has gone.
Screen is gone. Can you see the screen now?
Yes, sir.
Yes,
No, sir.
Yes, sir.
You can see everybody. If you are not, if you do not see, then say you cannot see. So everybody can see the screen. Okay, so from here, what we observe is that now let us say that this new matrix I3 dash, we denote this new matrix by P.
Excuse me, sir.
Yeah.
Sir, it is showing your screen share will never be stored locally or remotely.
You cannot see the slides.
Yes, I can see the slides.
You can see the slides?
I can see the slides, sir. I can see your screen, but not the slides.
Okay, so let me close the screen again and then I can share it again.
Sir, if you don't mind, can we do the next classes in MS Teams?
I will try, but I need your help also to make this MS team because I have around 120 students and it's very difficult to add all of them.
Sure, sir.
Or you already have an MS team?
Only
Yes, sir.
generating.
All our classes are on
Yes,
MS.
sir.
Classes are on MS Teams.
Yeah, the MS team is very suitable. But do you already have an MS team there? Like
Yes, sir, we
or
have.
I am teaching
Yes, sir.
Yes, sir.
hang on a second. I am teaching S3, S4, S5, S6, S7. These batches. So do you already have a team for these batches?
Yes, sir.
You don't have.
We are
Sir,
not
give
sure
the
about it,
links
sir.
to the
Sir-
CRs will do the work.
Sir, you made a couple of us CR and said each batch should make their own team and add our teaching assistant class. So we did that.
I need the CR to add everybody, not the batches. Like because I have to just make just a single team. Okay, so that means so I need somebody who can add all the students of the batches S3, S4, S5, S6, S7 in a single team, and then we can go with the MS team.
Sir, how will the CR get those emails?
Which email?
I think
Sir,
we
I
can
will have to
directly mail all the
their
students
email
of
so
any
that I can
particular
send them the
batch.
link.
एक एक करके बोलो. Which email?
Sir, I was saying that if we want to add everyone, then we need to have their email so that we can email them the link of the group.
I think using
The
this, we can get in touch with the students of all the sections. If we just do s3@iitr.ac or ac.in, then every student of S3 will receive that particular mail. So communication will be easier. Yes, sir.
so you
This
mean
will
to
do.
say that I add a team here, create a team here, a class, and let's say this is name of the team is MN001, and then what do I do? How do I add the members here?
So the three dots on the right of MAN, you click on that, and then there will be an option of manage team members.
Three dots on the
Right beside MAN 001. Yes, sir. Manage members, and then here there should be an option to add. Yes, sir.
so you
Add.
if I write S3, no, I do not get. I have to write all
Yeah,
the
that I don't know, sir. I think you'll have to add it individually.
individually. So that is a very cumbersome task.
Excuse me, sir.
Yes.
Sir,
Sir, like you send the batch, every student you send the mail of link. So in one such mail, you can send the invitation.
How do I do this? We can do it now.
So for that you'll need either you need to create a code or you can
No, you just
you-
guide me because I'm not that much familiar with this team.
okay, so you'll have to go in the same you just click the menu button, the three dots,
Yeah.
and then here just a minute.
Sir, if you see the chat, Arav Ratra has sent a email ID. So if we type s3@iitr.ac.in,
Hmm.
so all the S3 members will receive the email.
So how do I do this? You asked me to.
Sir, actually I
Sir, you
don't
have to
know how to
type this in Gmail, sir.
Sir, I can tell you how you can create a link from a laptop. So you can add me and then I'll generate a link and send it to you.
Okay. Shall I open my laptop?
Yeah, that'll work too. Or else you can just add me and then I'll create a link and send it to you on WhatsApp. And then
So
you can mail that link
so
to
you
everyone.
mean to say that I go to this three dot, then I write manage, then add, and then write your name.
Yes, yes, sir.
What is
Ayush _A_, Priyadarshi.
A_?
Priyadarshi. Yeah, the last one. TRIY.
This
Yes,
one.
sir. Yes, sir.
Okay. And now what is
Done.
done? Okay. So then,
Yes, sir. Now I'm added, so I'll get a link to the team and I'll copy it and I'll put it on the group which you made for the CR, and then each CR can share
forward it
the
to.
for to their respective batches.
Okay. Okay. So and in that way they can join. They
Yeah,
can.
yeah. So you'll get requests. You'll get requests to add us. We'll click on the link and send you the requests, and then you can accept us, and we'll be in.
Okay. Okay. Very good. So that we can do.
Sir, I've sent the link to the MAN 001 CR group, which you made for just for the math CRs.
On the WhatsApp.
Yes, on WhatsApp.
The better option would be to send a link in the chat box. Everyone can join now.
I'll send it on the chat as well. There you go. It's in the chat as well.
So okay, you can just see if people can join. Try to join now.
So to accept the requests, there's an activity tab on the left bottom corner. So
Where?
that's where the requests will come. Left bottom corner.
Left
Bottom corner, sir. Activity
activity.
tab. So all the requests should come here.
I'm getting something on my laptop.
So on and so forth.
No, this is something else. Where is the team? Okay, so I think I'm getting something on this my laptop. Archit Gangwal.
Yes, sir.
Okay, and Bhukia Naresh. So I accept all.
Yeah, you can accept all at once. Once you have 15, 60, 70 requests, you can accept in one tap everybody's request. So
Okay, so I
you
accept
can either
all.
wait or you can accept one by one. That's your choice, sir.
So there is a better method. So there is a better method. You can simply share the code of the team from the settings
Yeah,
tab.
but I don't know how to guide sir to generate a code on an iPad. I know how to do it on laptop.
So
But
where you are on the pending request, aside uh, a channels option will be there. Then a settings option is there. Under the settings, team code option
No,
is.
no. So I opened my laptops and whatever request I'm receiving, I'm accepting. I don't know whether they are added or not.
So in the laptop from where you are taking the request, pending request,
Mm-hmm.
aside that there is an option channels and after that settings.
For some reason, when I accept, it's showing some problem because of the internet or.
so should I share my screen and show how to generate a code?
Yeah. That will be helpful. So for that, I need to stop sharing.
Yes, sir.
Okay.
Yes, sir. So can you see my screen?
No, not yet. Yeah, now I can see your screen.
Yeah, so in Teams on the laptop, you go to the team and then
Yeah.
here menu and manage team.
Then menu, manage team. Okay.
Yeah, so for example, I made this group, made this team and then manage team. No, sorry, not this one. This one. Yeah. So manage team and then here settings.
Settings.
And then the team, there will be an option of team code here.
Okay, so team. I click on the team code.
And then you'll have to generate, if it's not generated, then you'll have to generate it
Generate. Okay.
and then copy it and then you can send it on the same group. So then you won't have to accept the requests.
Okay, so this code is 0Q. So just the code.
Yeah, so you can just copy and send it on the chat or
I'm
on the
sending
WhatsApp
on.
group.
I'm sending on the email. Just the code. Just the code, right?
Yes, sir.
Yes, sir.
That's all it's needed.
So S3, S4, S5, S6, and S7. Okay, so the subject is code. So now I have sent the email. Can you check whether you have received it?
Yes, sir. Just a minute. I'm refreshing. Yes, sir. I did receive the email. 0Q4CJOE.
Yes.
Okay, I've received I think everybody has. So
Yep,
now
So
sir.
they can
now,
direct. So now you won't have, if they use the code, then you won't have to accept the request. They can directly enter. And if someone uses the link, then you'll have to accept the request.
okay. So now everybody should be in. So just try to use the code and get in the team. So is it like they have to do this, put this code every time they enter the
No,
team?
sir. Once they're in, then whenever you start a meeting, they'll get a notification, and then they can directly join the meeting.
Okay. So can you do it now in the next 1 minute before
Sir,
we
the
finish
code
this?
you shared is for 629, I think, not for
Uh,
001.
wrong team is shared.
I have
So it
used. Oh, I
generated
have
it with wrong team.
wrong team.
Yes, sir. 629. MAN 629 is shared.
629. I have shared this one. Oh, so let us do it again. So this is. But I have couple of members here now. And then you said go to. Okay, I have to do this on laptop, right?
Yes, sir. 3 dots and then manage team and then settings.
So Teams. Manage team. Setting. Then team code. Generate team code. Okay. Copy. Send it again. So now I'm sending the new code. So it is sent. So it is sent. So just check and try to get inside the team.
Yes, I've received it. WJ8C5UQ.
Yes, yes.
Okay, so sir, from next class the lectures will be on Teams, not on
On team.
WebEx.
On team, yes.
Okay, so now we can leave because we have next
Yeah,
class.
you can leave. We can
Okay.
discuss this thing in the next lecture.
Okay. Thank you, sir.
Okay. Okay, thanks.
Should
Thanks
Thank you,
for
sir.
the-
Thank you, sir.
Should
Thank you, sir.
Thank you, sir.
Thank you,
So
sir.
should we leave that MN 6 to 9?
Yeah, leave that group, yes. 6 to
Okay.
9, leave that group.
Thank you, sir.
Okay, thank you, and I'll see you on Thursday.
Okay.
Okay, sir. Thank you.
Okay, bye-bye. Take care.
Thank you, sir.